Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will discuss about the synchronization in pthread of API, and we will discuss about different mechanisms of implementing this pthread API synchronization. As we have seen that Solaris synchronization gives the same scheduling policies for user level and kernel level thread, but mainly they are implemented within the kernel. In contrast, POSIX pthread API provides an user level thread synchronization mechanism outside the kernel, which is a not direct intervention of the kernel. Now they can be done with the help of mutex, semaphores and condition variables, also read as writers logs. Now mutex is the fundamental synchronization mechanism provided in the pthread API. In pthread, mutex are used to protect the critical section of a process. Now that a mutex log should be acquired before entering the critical section, and after accessing the critical section, it should be then release the mutex log by that particular process. Now the mutex object in pthread is described as a pthread mutex t data type, and it can be initiated with a pthread mutex init function, where it will be given different parameters. The first parameter is a pointer to the mutex object, and by passing null to the second parameter, we are telling that we are using only the default values of this init function of this particular mutex object. Now we will see what is the basic structure of this pthread mutex init function. First, we are declaring a variable mutex that is of data type pthread mutex t. Now we are calling the pthread mutex init function to create the mutex object upon calling it with the pointer to the mutex variable and the null function. Now, these mutex logs can be acquired and released by the pthread by the pthread mutex log and pthread mutex unlock function. Suppose that a function or a process that wants to acquire a log using the pthread mutex log function, where the log is held by another task or thread, then it will be blocked. The acquiring process will block the requiring processes and put it in the waiting queue. And when the owner will release the log using the pthread mutex unlock function, then the process will resume its execution. So generally the entry section and critical section, also exit section, is performed in this way. First, in the entry section, we are acquiring the log using the pthread mutex log function and passing a pointer to the mutex variable that is of pthread mutex t data type to this function. Upon exiting from the critical section, it will release the log. This is the exit section of this block. Now the semaphores and the reader-writers logs can be implemented in their own description. All mutex function will return a 0 on successful completion, and it will return a non-zero number if there are program error or system failure happens during the execution of those functions. Now semaphore can be also introduced as a synchronization mechanism in pthread. Although it is not included in the pthread standard, it is included in the POSIX same standard. The semaphore in pthread are of two types. One is named, another is unnamed. The main distinction between these two types is named semaphore is actually has a name in the file system and that can be called by several unrelated cooperating processes. Whereas an unnamed semaphore does not have any kind of name and can be called by the threads which belongs to the same process. So now we will describe a code that will initiate the same init function to create and manage the semaphore. First, we are declaring a same variable of same t data type, that is the data type used for semaphore in pthreads. Now we are using this same init function to create the actual semaphore. So now there are passed three parameters to this same init function. The first is the pointer to the semaphore value. The next is to indicate the level of sharing, and the third one is the initialization value of the semaphore. So here is a pointer to the same variable which is a current semaphore of same t type. By declaring 0 as indicating the level of sharing, we are telling the operating system to create a semaphore that will be used by the only threads belonging to the same process. No unrelated process can call on this semaphore. And now the last, we are initializing 1 to the semaphore value of same. Now in the second parameter, without describing 0, any non-zero value will allow another processes or cooperating and unrelated processes to call on this semaphore by pressing the non-zero number. Now along with this semaphore wait and signal classical description, here we call it same wait and same post function. Now we will describe that how semaphore can be implemented using these two functions. Invoking this same wait function to a pointer to the semaphore variable same, we are acquiring the semaphore as the entry section. Now to release the semaphore, we will use the same post function. It will be included in the exit section of this code. Now, as of the mutex logs, all functions related to semaphore will return 0 on successful completion, and if there any error occurs, then it will return a non-zero value. Now, along with this semaphore, reader-writer log, mutex logs, and condition variables, pthread also provides some implementation of the spin lock mechanism. However, the portability from one machine to another machine is depending on these mechanisms. So in this way, pthread can synchronize among its threads at the user level without the intervention of the kernel. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.